Lightning splits the Roman sky. Thunder shakes the earth. And inside a 2,000-year-old temple, rain pours through a giant hole in the ceiling. Yet the floor never floods. No pumps. No modern drainage. Just ancient engineering that still works perfectly today. How did civilizations without computers, steel, or electricity build structures that outlive empires while our bridges crack in half a century? All SCRIPT. Step inside the Pantheon during that storm. Water crashes through the oculus, striking the marble floor in shimmering sheets. You expect chaos. You expect puddles rising, stone darkening, centuries of history slowly dissolving. But instead, the rain vanishes. Beneath your feet, hidden drainage channels quietly carry the water away. Systems designed nearly 2,000 years ago, still functioning with silent precision, now steep back into our own time. Highways buckle, overpasses fracture. Residential towers demand major repairs after just 40 or 50 years. We pride ourselves on progress, on algorithms and skyscrapers and reinforced steel. Yet the uncomfortable truth stands in the center of Rome. Ancient builders created something far more durable than much of what we build today. And it wasn't luck. Their secret wasn't simply better stone or stronger sand. It was mindset, a philosophy of construction. They didn't design for decades. They designed for centuries, for climate shifts, for invasions, for earthquakes and erosion. Their structures were meant to endure political collapse and natural fury alike. In the mid-20th century, construction crews uncovered a buried Roman wall. Confident in modern machinery, they attacked it with hydraulic hammers. One machine failed, then another. Drill bits dulled and snapped against material that had been underground for 2 millennia. When scientists finally analyzed the concrete, the results were staggering. Time had not weakened it. Time had strengthened it. For years, researchers noticed tiny white lime clumps inside Roman mortar and assumed they were mistakes, evidence of poor mixing, careless craftsmanship. But modern chemical studies revealed something astonishing. Those clumps were intentional. They were the key. When cracks form, rainwater seeps inside. It touches those dormant lime fragments. A chemical reaction begins. The lime dissolves, reforms and fills the fracture with fresh binding material. The wall heals itself. No maintenance crews. No emergency repairs. Just chemistry patiently doing its work. Imagine that. A building that repairs its own wounds. And this philosophy extended beyond land. Along the Italian coast, Roman harbors stand battered by waves that have pounded them for over 2,000 years. Salt water should destroy concrete. It corrodes, erodes, eats away at structure. But Roman engineers reversed the equation. Seawater doesn't weaken their peers, it strengthens them. The water triggers the growth of rare minerals within the concrete, slowly knitting it tighter, denser, more unified. With each passing decade, while modern ports crumble after 30 years, Roman breakwaters gradually transform into monolithic rock. They didn't fight nature. They enlisted it.to. Them, ash, lime, and water were not simple ingredients. They were partners in a slow, deliberate process. Construction wasn't a race against deadlines. It was a dialogue with physics, chemistry, and time itself. And Rome was only the beginning. Travel 1,000 kilometers east to the base of the Great Wall of China. There, hidden between bricks, weathered by centuries of wind and war, scientists discovered something unexpected: sticky rice. Not metaphorically, literally. Ancient builders mixed rice porridge with lime to create one of the world's first composite materials. Inside that mortar, a special starch called amylopectin formed a microscopic network, flexible, resilient, incredibly strong. Where ordinary stone would crack under stress, rice mortar absorbed the shock and redistributed it. The wall could flex without failing. Food became fortification. Chemistry became defense. Precision was everything. Supervisors tested joints with hammers. If a brick shifted, if a mark remained, punishment could be severe. Craftsmanship wasn't just skill, it was honor. Cross the ocean to the Andes, and the lesson evolves again. At Sacsayhuaman and Machu Picchu, the Inca shaped colossal stones into interlocking forms, so precise that even a blade cannot slip between them. No mortar, no cement, just geometry. In earthquake-prone terrain, they built what could be called living masonry. When tremors strike, the stones shift slightly, absorbing seismic energy. Then gravity settles them back into place. Flexible, adaptive, alive. In Egypt, the pyramids rise with mathematical obsession. Foundations leveled using water channels. Massive blocks placed with geometric intent. No steel to rust. No cement to decay. Their power lies in simplicity, mass, alignment,